Hello, welcome back to Dynamic Meteorology. So for today, we will be discussing another equation from the set of basic equations that we're using to quantify the fluid motions in the atmosphere. This is continuity equation, which is derived from the conservation of mass. It says that mass is not created nor destroyed. So the total mass of the atmosphere, to a very close approximation, is constant over time of periods of interest. Okay. Conservation also means that in an isolated system, that parameter remains constant. It's not created and not destroyed as what we've said, but it can move around. So for continuity, it means that the fluid is continuous, therefore there are no holes in the fluid. This is a fundamental assumption underlying atmospheric motions. Okay. So for today, we will be deriving the continuity equation. This is from a simplified version of what we have in your books in Halton. So let's begin. Imagine that you have a cube at a fixed point in space. Ibig sabihin, your cube is not moving, it's just there, but fluids can come and go to this system. So, kahit saang part. Okay? Alright? The net change in mass now is the question. So, kung may pumapasok na let's say air parcels or wind or whatever it is at this point or at this fixed cube in space, what is the net change in mass contained within the cube? Now we're looking to the variables na pwede nating makita dito. So we have your volume, of course, which is the product of dx, dy, and dz, which is the distance in your x, y, and z direction, your density, which is mass per unit volume, or defined as rho, and therefore your mass is equal to density times v, or rho v. Para malaman natin kung ano yung net change in mass, the net change in mass contained within the cube is found by adding up the mass fluxes entering and leaving through each face of the cube. A flux is a mass that enters at a certain speed or velocity into the certain face of this cube. Therefore, we can quantify your change in m, or change in m over change in t is equal to your rho, or the density, of course, because your density times your velocity. This is your mass flux. Now, to know the mass flux of this system, we need to get the net change of it. Therefore, we need to get change in m over change in t is equal to m in minus m out. Okay. So how do we do that? Expanding this equation, we have your rho times your velocity times x. Sabihin natin na may pumasok na itong arrow na to. You have x, so dy dz minus, ito na yung out niya. So this is your in and your out. So you have change in u, rho u pala, x plus dx plus dz dy dz. So this is your change in m with respect to time is equal to rho u times dy dz. Ito yung sa x direction niya upon entering, and ito yung paglabas niya dun sa fixed cube. Now, we can do that into 3 dimensions. So, let's say na meron kang flux dito entering this face of the cube here and also dito sa likod. We can expand that equation as well and get the m input. M in is equal to your rho times your velocity x dy dz plus rho your v dahil UVW, remember that, y dx dz plus your rho w z dx dy. Okay, so now we look into the outgoing, yung palabas. We have your m out is equal to your rho u, that's x plus dx dy dz plus your rho v y plus dy dx plus dz plus your rho w subscript z plus dz dx dy. Okay, so now that we have that in 3 dimensions, so ito yan siya, ito at itong side na to ng cube, dyan sila lumabas. You have your m is equal to rho dv, that's equal to p dx dy dz, and your change in m is equal to d zero dt dx dy dz. Now we want to substitute your m in minus m out is equal to change in m over change in t. So gusto nating yung m in mo ay ito, yung m out mo ay ito. So maya gusto natin yang i-substitute sa ating equation. Okay, let's write that up. This will be a pretty long equation. And want to simplify this equation more, so we divide both sides by dx, dy, and dz para hindi ganun kahaba yung equation. So dx, dy, dz, dx, dy, dz. So this term here cancels out and we are left with x plus dx all over dx plus rho v y minus rho v y plus dy equal dy Simplifying this equation, we are left with negative change in rho u or change in x minus dv over dy rho w over change in z is equal to your change in rho over with respect to time. And this gives you the very basic equation for continuity, which is change in over change in p plus n u over change in x v y w over change in z is equal to 0. This just means that your change in density with respect to time plus the momentum flux in the 3 dimensions, when you add it up, it is conserved or it is equal to 0. You can also express this in vector form, which is rho, bakit p? Kasi rho over 80 is equal to your negative p times your times v, or this is your gradient operator. You also saw this on our material derivative. Therefore, ang interpretation lang naman ito, itong whole equation na to, is that the change in density at fixed point in space, yung fixed point in space natin, is dependent upon the divergence of mass flux. Yung pag sinabi natin divergence, ibig sabihin, yung pag-divergence, these are topics that we've discussed before, but now we are looking into how we express it mathematically. Divergence means that yung gradient operator mo times rho v, this is your volume, hindi to yung flux kanina, is greater than 0. Therefore, yung density mo will decrease. Means that your density will decrease. Therefore, mas marami yung mass that's going out doon sa cube kaysa doon sa mass na pumapasok doon sa cube mo. Pag convergence naman, it is the opposite. Convergence equals is less than 0. Therefore, your density increases. So, ibig naman sabihin ito, mas marami yung flux na pumapasok doon sa fixed point in space mo kaysa doon sa lumalabas. By the way, this continuity equation na dinerive natin ay para sa Eulerian reference frame. So, Eulerian siya. How about kung Lagrange? Sa Lagrangian reference frame, ang difference lang niya is that yung fluid parcel ay capable ng pagdi-deform or it is deforming. Doon sa Lagrangian, hindi siya magdi-deform. How do you compute for the continuity equation for Lagrangian scale? We do that by E is equal to U. Gagamitin natin yung product rule para sa solution na to, product rule, and we just use the vector identities. Vector identities. Nakanasulat ko. Okay. We use the vector identity na is equal to rho v u plus u dot grad rho. And by collecting terms or grouping your terms, you get this equation change rho over change in t plus u dot grad rho is equal to minus rho grad dot u. And this one is actually your material derivative, which we discussed last time, and you're left with your Lagrangian Lagrangian continuity equation na P, that's rho, sorry for that, rho over dt is equal to minus rho v. Okay. Alright, so now you have your continuity equation both for your Eulerian reference frame and your Lagrangian reference frame. It's almost the same, yung dalawang yan. So, this one and this one. For your activity for this lesson, what happens, anong mangyayari sa equation, sa continuity equation, if your density doesn't change? Density doesn't change. Okay, so this activity, I want you to submit a derivation of the continuity equation kung ang density niya ay hindi magbabago. Okay, so that would be all for this lesson. Thank you.